Hello and welcome to Learning Economics. Dear viewers, we have been working with the data till now. We have talked about various types of the data in brief. However, we have not studied the types of data explicitly. I have kept telling you that we shall study them in detail in future. And now I think it is the time that we explore various types of the data in detail. So let's start with logical operators or Boolean data. Logical vectors are simplest type of vectors in which each element can only be one of the three possible values: true, false, or NA. It's relatively rare to find logical vectors in raw data, but we shall create them and manipulate them in course of almost every analysis. So in this lecture, let's discuss about those. A very common way to create a logical vector is via numerical comparison with greater than, greater than equal to, less than, less than equal to, and not equal to. For more explanation, let's turn to RStudio screen. Let's load tidyverse. And we shall also load the New York flight data. And following our best practice, we shall display it or view it first. Now, let's assume that we want to filter all daytime departures that arrive roughly on time. By daytime, I mean those flights that flew between 6:00, that is 6 a.m. in the morning, till 20:00, that is 20:00, that means 20 hours or 8 p.m. And by roughly on time, I mean arrival delay was between 20 minutes in absolute. That is, either they arrived earlier but not more than 20 minutes, or they were delayed but not more than 20 minutes. For this, we can use lights and then this, and then we can use filter. Okay, and we can use arrival time is equal greater than or equal to 6:00, and arrival time is less than 20:00, and ABS is for absolute. Arrival delay is less than 20. So we have all these flights, and these are 3402 rows in this data. However, we can also do this in another way, in logical vector format, and we shall use mutate function for this purpose and work like, for example, the lights and then pipe function. Then we shall use mutate. Mutate, is used to create new variables. So we are creating two new variables. One is for the daytime, for which we have the criteria that the arrival time should be greater than or equal to 6:00, that is 6 in morning, and it should not be greater than, or in other words, it should be less than 20:00. And then we have another criteria that is roughly on time. I am naming it like this. And for this, we have the criteria that arrival delay should be less than 20 in its absolute form. And we shall use another argument which I shall tell about that later on, that is dot keep is equal to used. So let's see those flights and see the output. Here we can say daytime true, roughly on time true, that yes, it adhere to both condition. Daytime true, but roughly on time false. Daytime yes, but roughly on time no. So only those flights which are both true are actually are of our interest. In this way, these are logical operators or Boolean variables. Now coming to this code simply says to create two variables. I'm not explaining this pipe function. I'm not explaining this mutate because we have already covered all these in very much detail in our earlier videos. If you have not watched those, I would recommend you to watch all those videos from video number 1 till here and so on. So we are just creating two variables. One is for the daytime, and for this we have the criteria that the time should be between 6 to 20, and here we will use AND condition so that both the conditions must be fulfilled. And then for the roughly on time, I have used absolute so that -10, that is arrival by earlier by 10 minutes, or +10, that is arrival late by 10 minutes, should be treated equally, and here the criteria is less than 20. This function dot keep actually tells data which variable to keep or which variables to display. You can see in the above output, it displayed all the variables. But here I am saying to keep only those variables which we have used. And we have used arrival delay. So this is there. We have used arrival time. So this is there. And using these, we created daytime. This is there. And we created roughly on time. This is there. So in this way, we can use logical operators. We shall continue our discussion on these logical operators or Boolean data, but it is worth important to talk about missing values here. However, we shall restrict our discussion in line with logical operators or Boolean data only. Viewers, missing values represent the unknown, and almost any operation involving unknown values will also be unknown. That is, that will be displayed as missing value or NA. Let's go back to our studio screen, and just for example, to help you understand what is coming up, I just ask R if 5 is equal to 4 plus 1, it is saying true. And if I write 5 is greater than 3, it will write true. And if I say 5 is less than 1, it will say false. So all this information is in the logical operator or Boolean data type. Now, if I involve the missing value, that is NA, and ask is NA greater than 5, it will say NA. If I ask if NA is equal to 5, it will say NA. And if I ask if NA is less than 5, it will still say NA. So any operation involving missing value will produce result that is equal to missing value. Another example, I am using some algebraic operation, for example, Na plus 10, it will result in Na. Similarly, multiply, divide, any operation will result in Na. Even if we ask it that whether Na not available or missing value is equal to Na, it will still say Na. So any operation involving missing value will always result in Na. Just keep in mind, and we come back to logical operator and connect these two. Sometimes for our analysis, it is important to use NA, any missing value or not available value as well. For this, we have a new tool which is.NA. Is.NA basically either asks a question or gives the answer, and it can be applied on numeric as well as non-numeric or logical or Boolean data. How? Let's see. If I ask it is.NA and then I write, for example, C is equal to 1, 5, 0.4, Na 3. It is, for first value, it is saying false. That is, it is not Na. Second value, not Na. Third value, not Na. Fourth value, yes, true, it is Na. And fifth value, false. That is, it is not Na. Now let's try it with some, for example, string variables. And you know, string variables are written in double quotations usually. So I'm writing A, I'm writing, for example, Pakistan, and I am then writing Na, and then I am writing, for example, Asia. And I am asking, is it Na? Sorry, I need to specify this in vector. So for the vector, I need to add this C. And it is saying, no, it is not. No, it is not. Yes, it is a missing value. No, it is not. So in this way, it is providing me answers. And I am using is Na as question. Another use of is Na, for example, could be in the New York flight data. We filter these values is dot Na, and we say depart underscore time. So it will filter all those values in which the departure time is Na, and it is telling me that there are 8255 such values or 8255 such rows. So if we are to use these missing values, we can use it using is.na extension. Viewers, that is all about today's lecture. In the next lecture, we shall explore another type of the variable. Please do let us know about your feedback in comments. Do like these videos if you really like them, and share these videos if you find them useful and find them helpful in learning data analysis with R. So see you in the next video. Till then, take care and bye-bye.